So welcome to part 2 of the lesson. Again, I don't have an aim for today because this is really just a lot of review of stuff that you should have seen in the past, but that we would like to prepare you for Algebra 2. So we're going to go over some basic stuff, and by basics, I'm saying basic because they are things that you should have learned, but they might not be necessarily easy. So don't be worried if you think that this is not easy, but hopefully by us reviewing it, it might make it a little bit easier. So to review, expressions. Expressions are numbers or symbols and operators such as like plus, multiplication, division, all that kind of stuff, that are grouped together to show the value of something. We've done this literally almost every day in geometry, where you're given a picture and you need to create a relationship between the things in that picture. When you create those relationships, they're usually expressions equaling other expressions or expressions equaling a number. So for example, when I say that the central angle is 1/2 the measure of the intercepted arc, you're creating an equation, which we're going to talk about what an equation is in a second, but you're creating expressions that relate to each other. Okay? So very quickly, which of the following is an expression? So hopefully you said that this one is an expression, because an expression is just numbers and symbols and operations that are grouped together that show the value of something. On the right, this is something different. It's an equation, but we'll get to that in a second. All right, so what can you do with expressions? Do you remember if I were to give you this expression, could you do anything with it? Yeah, so hopefully you said like terms, right? You can combine like terms. So like terms are terms that have the same variable so that you can combine them. So we got 2x squared, but negative 5x plus 2x, you can combine that, right? So if I have two things and I take away 5 away, I actually have a negative amount of things, right? So with expressions, you can combine like terms. Now again, there's a lot of things I'm skipping. There are different ways you can combine like terms, but we're going to keep it just like this for now. All right, so equations. An equation is simply a statement about equality of two expressions. In other words, anything that takes the form of an expression equaling another expression. So it's funny, you might not have thought of it this way. And again, this is what I've been saying in geometry. You are always creating equations that relate to expressions. And those expressions relate to real things. So for example, if I said, and I said this before, let's do something else. Supplementary angles. Supplementary angles add to 180 degrees. Those are two expressions. Two angles equal 180. Those are two different expressions, and they're equal because they have a relationship between each other. Okay, so exercise 1, which of the following is not an equation? I don't even know if I said that. I'll have to check the video. So this one is definitely not an equation. And I'm going to be super clear. Equations, they have equal signs. That's the easiest way to know if something's an equation. It has an equal sign. All right, consider the equation 2x minus 8 equals 10 minus x. Why can't you determine whether this equation is true or false? Now that might be a silly question. It might be a silly question. You can't determine if that equation is true or false because you don't know what x is, right? So I know a lot of us jump to, okay, just solve it, solve for x, substitute back in, if it works, you're good, right? That's what you've been taught all of your life, right? But abstractly, right? Why can't you determine if that equation is true or false? Because you don't know what x is. So now question B, if x equals 5, will this equation be true, and how can you tell? Well, what is that called when you want to check a solution? Substitution. So we can substitute in 5 and see if it holds true. So we're going to do that right now. Okay, so check this out. I substituted in 5 for x. So everywhere I saw x, I replaced it with 5. Now, here's the thing. It may be silly to do this now, but I'm telling you, and I know we've said this during the school year, anytime you substitute in, use parentheses. When things get more complicated, especially in Algebra 2, when you're doing a lot of like negative exponents, square roots, different types of radicals, really larger equations and formulas that you're going to have to use, it makes it a lot harder when you don't use parentheses, because your brain, when you put parentheses, your brain is kind of telling you what to do first. So for example, if I didn't put parentheses here, I might do 5 minus 8 first and then multiply by 2. But that doesn't make sense because we know we need to multiply first. So I'm just going to simplify this. Is that true? Nah, those aren't equal. So x can't equal 5. So solutions to equations. A value for a variable is called a solution to the equation if, when you substitute it back into both expressions, the results in the equation are true. So when we substituted in 5, we saw that the results were not equal, therefore it's not true. So let's do an example. So here's an example. Does the following value of x solve the equation below? So I encourage you, pause it, try it on your own. There's some fractions. It's okay. Okay, so let's do it together. We're just going to substitute in 10 anywhere we see x. So there's an x, so it's going to be. So 10 minus 20 is negative 10. I'm going to write it over here. Negative 10 divided by 5 is negative 2. Is negative 2 equal to negative 4? No, it's not equal. So that does not work. Okay? So the value of x does not work in this case. All right, so at this time, I'm going to tell you the password. The password for this week is music. Okay? So when you clicked the assignment or the materials for this video, you're going to see the form next to the video. Click on that form, fill out the information. Your password is music. Remember, this is the only assignment that you are not allowed to make up, because this assignment shows you that you actually watched this video. Okay, so let's move on with the lesson. All right, the most important thing, in my opinion, in my professional opinion, is learning how to solve equations. If you can solve an equation, it makes a lot more complicated things easier. And something that myself, Miss Fu, and Miss James, we all use in our classes for algebra is something called Don't Call Me Impossible. It's a silly little acronym. And each letter of the acronym stands for something. And this is really the order in which you use to solve equations. Now, to be fair, there are many ways to solve equations. However, since we notice that a lot of students have trouble with solving equations, this seems to be a great thing to use if you're stuck. So the steps are distribute, combine like terms, move the variables to one side, and then use inverse operations to isolate the variable. So we're going to do, I think, 3 examples of this, and then we're done for today. This is Mr. D'Souza from the future. I just wanted to say one more thing that is crazy important when solving equations. Yes, you got to do these steps, or there's other things that you could do. But the most important thing as well to take into consideration is whatever you do to one side, you got to do to the other. Okay? That's really the rule. If you follow that rule, you can basically do almost anything you want to equations to solve them. So just keep that in mind. I am telling you this. One of the fundamentals that you need to learn in mathematics to be successful, in my opinion, in addition to all those algebraic rules, is solving equations. Okay? These are tools to help you do higher level mathematics. Okay? And for those who are interested in doing pre-calc and calculus, the different higher level math that we offer, or rather that we're going to be offering next year and the years to come at BTech, these are skills that you just got to know. You got to know how to do these things like this, because in real mathematics, what we learn right now are the tools to be able to do those things. All right, so let's do this. Again, if you can solve this on your own, just do it quickly. Move on to the next question. no need to wait for me. But if you are someone that you're like, you know what, I kind of get stuck on doing these problems, stick with me. Okay, so we have this example. We want to solve for x. Now, yes, there are a bunch of ways that you could do this. Some ways that you think that you might not be able to do. For example, I can move that -2 to the other side. I can divide both sides by 4. I can do a lot of crazy things that maybe you may not know that you could do. But I want to stick with our steps because our steps will always work. So let's kind of do it together. So the first thing is to distribute. Can I distribute? Yeah, there's distributing right here. So 4 times x is 4x. 4 times 1 is +4. Minus 2 equals -6. So I'm done with that. Ask yourself, can you combine like terms? Are there any terms that are the same that you can combine? Yeah, right here. So we're left with, okay, so we combine like terms. Now we need to move the variable to one side. Ask yourself, is the variable on one side? Yeah, it's chilling right here. It's on the left-hand side. If the variable was on like 2 different sides, that's a different story. So we're done with this step. Now we just need to use inverse operations to isolate the variable. Okay? Again, there are multiple ways that you can do this. Multiple ways. But I'm going to do it the way that you probably have seen it before. So I want to get this 2 out of the way. The inverse of +2 is -2. All right? Now I want to get x by itself. I can divide by 4 on both sides. And then I get that x is -2. Now, check your work. Let's check our work. I'm going to speed this up. All I'm going to do is substitute in, simplify the best that I can, and hopefully I get 2 things that are true. Done, it works. We got 2 things that equal each other. We're good, we're moving on. Reminder, the password is music. How can we solve the following equation? We're going to do this in 2 different ways. First way that we're going to use is my steps, and then I'm going to show you another way to do it. Because again, if you already know how to do this, this is mad boring. But I want to show you other ways that you can approach different problems. Okay? So we're going to do it the first way, which is don't call me impossible. Can I distribute? There's nothing to distribute. Is there anything to combine like terms? Technically, you can make this 7/1. You can add the fractions and then do more stuff. I'm not going to do it that way. I think it's going to be a little bit more complicated, but it would still work. Again, if you're interested in like these other cool, in my opinion, very cool ways to solve equations, reach out. I'd be more than happy to show you. Maybe sprinkle a little extra credit if you ask. That'd be awesome. So there's nothing to combine. Is the variable on one side? Yeah, it's on one side. So we just got to use inverse operations. So remember, whatever you do to one side, you got to do to the other. So some of you might be saying, like, why can't I just +3 on both sides to get rid of this? Well, you can because technically it's in a fraction. So let's get rid of that fraction. Remember, fractions is just division. The opposite of division is multiplication. So if I multiply both sides by 2, you get the following. And then we just add 2, and then we just do the inverse of -3, and we do +3, and we get our answer. Boom. I encourage you, try to do this. Try to check your work. Substitute in 35, see if you get the same answer. Okay. Now I'm going to show you a different way. This is a more advanced way, I guess, to do this. It's not necessarily easier. It's all about preference. If you know how to work with fractions, it's a lot nicer in my opinion. But like I said, there's technically an infinite amount of ways you can solve equations, because whatever you do to one side, you can just do to the other, in most cases, and that's mathematically correct. So the way that I'm going to approach this next problem is I'm going to get rid of the fraction first. Let's say I don't want this dividing by 2. We could multiply by 2, but there's an issue. There's an issue in this case. If you want to multiply by 2, everything needs to be multiplied by 2. So you got to do it like this. Okay? Distribute the 2. Now, this 2 divides out this 2, which is what happened over here. So you're left with x minus 3. Okay? 7 times 2 is 14. And that equals 23. And that equals not 23, because remember, whatever you do to one side, you got to do to the other. 23 times 2 is 46. Combine like terms, so we got x, 14, 13, 12, 11, so that's 11. I want to get x by itself, subtract 11 on both sides. And I get x equals 35. Different method, got the same answer. I like the method on the right-hand side because I like to kind of get rid of my fractions. Because usually with fractions, unless you are very precise, it's very easy to make a mistake. So I like to do that. If you're like, nah, I have no idea what you just did, that's okay. You can do the method on the left-hand side. But again, trying not to bore people for those who do know how to do this, but I also want to accommodate for those who actually need extra help with this. So let's do another example. I encourage you, pause the video, do it on your own. First thing I'm going to do, I'm going to just use my don't call me impossible rules. I'm going to distribute. I see I have a -6. I can distribute that out. So I'm left with. Beautiful. Let's combine like terms. Now, hopefully you have either your phone or your calculator next to you, because it'd be very silly to make a procedural error, which means that you just added 2 things wrong or you multiplied 2 things wrong. And again, if you ever catch a mistake that I make, I try to not make mistakes so that these videos are accurate, but I make mistakes all the time too. So if I make a mistake, please let me know. If you're in my class, I'll give you extra credit. Let's combine like terms. So these are like terms, 9 and -6. That is +3. -8 and 27. I'm going to just double check my calculator. 27 plus -8 is 19. So we got 2x. +19, so plus 19. Now move the variable to one side. Do you see how my variable is not on one side of the equal sign? You should be saying, yes, it's on the left and the right. So you want to make it to be on the one side of the equation. Now, you can either bring over the 2x to the left-hand side, or you can bring the -6x to the other side. It doesn't matter. So long as what you do to one side, you do to the other, you're going to get the same answer. So I'm going to bring over the -6. So the inverse operation of -6x is plus 6x. And you're left with, I'm lagging, you're left with 3 is equal to 6x plus 2x, is 8x, plus 19. I'm going to subtract 19 on both sides, and I'm left with the following. Solve for x, inverse operations that I've been doing. I'm just going to divide by 8 on both sides. -16 divided by a +8 is a -2. So x equals -2. I'm done. Check your work. Substitute it back in and see if it works. It does work. Okay, but you should check. Let's do one more question. You're probably like, OMG, this is crazy. It's kind of the same thing that we just did. It just has fractions. So we're going to take this one step at a time. Again, if you feel like you can do this on your own, do it on your own. Skip to the end and see if you're right. Okay? But if you're like, man, this looks really crazy, stick with me. Let's do it together. Okay, so the reason why I taught you a lot of those facts in the beginning is because we've been using them throughout the whole lesson. So we're going to distribute first, as it says here. Times 2, that's the same thing as 1 times 2. 2 divided by 2 is 1. So 1 minus 6x times 1/2. So that's 6x times 1, which is 6x. I'm going to leave the 2 on the bottom. You know what? I'm going to actually just do this. 6 divided by 2 is 3. So this is the same thing as 3x. If you don't believe me, use your calculator. 1/2 times 6 is going to be 3. Minus, we're going to distribute this. So this, remember, this is a -4. So we're distributing a -4. So it's going to be -4x plus, I lied, not plus. I'm getting ahead of myself and it's lagging. Negative times a positive is negative. Now, negative 4 times 3 halves is the same thing as negative 4 times 3, which is negative 12. Negative 12 divided by 2 is negative 6. And again, just use your calculator. Negative 4 times 3 divided by 2 is negative 6. I don't know if you can see that. Whatever. Believe me. Equals. Now remember, anything outside of the parentheses is technically a 1. So technically, this is negative 1. So we're going to distribute a negative 1. So we get negative x. Negative 1 times negative 3 is positive 3. And we're just left with 4. Combine like terms. So I have this, and I have these to combine. So I'm left with 1 minus 6, which is negative 5. Negative 3 minus 4 is negative 7x. And again, I'm doing this in my head, but if you can't, use your calculator. There's nothing wrong with using your calculator. Equals, I can combine these two. So we got negative x, 4 plus 3 is 7. Cool. My combining like terms is done. Next, move the variable to one side. I'm going to move this 7 to the other side. So I'm going to add 7x because that's the inverse operation. We're going to subtract 7 on both sides using inverse operations. And then I'm going to go down here. And I'm going to put what we got. So negative 5 minus 7 is negative 12 equals 6x. Divide by 6 on both sides. Negative 12 divided by 6 is negative 2. And that equals x. Weird that all the answers except for one were negative 2. It's actually really funny. Again, I encourage you, check your work, substitute it back in. Now, I'm going to be honest, this is kind of annoying to substitute in on your phone because it's a lot of fractions. If we were in school and you had your calculators, you could just use your calculator, literally put all this in. If you don't know how to solve equations, this is like my summary, okay? If you don't know how to solve equations, this entire lesson probably was complicated. To learn how to solve equations, you need to practice, and you're going to have practice problems. You may or may not have a different exit slip and purposeful practice this week. We're really trying to prepare you for Algebra 2. And I think one of the things that I can do to really help you with that is with these algebra facts. Factoring, substitution, solving equations, very important things. But I am going to relate them to geometry stuff. So next week we're going to talk about pizza. It's actually a story that happened between myself, Miss James, and Mr. Ability. Literally right before this whole pandemic happened. But I encourage you, if this is complicated, you need to reach out. The only way to get better is to practice, make mistakes, and learn from them. And with that, have a great day. I'll see you later, everyone.